All right. Let's see. Is this thing on? All right. So, I'm Dave Rand. I'm filling in for Professor Dunham today, and it's fun to talk to all of you and hopefully sort of try and introduce you to the world that I spend all of my time thinking about, which is cooperation, sociality, altruism, all these features that are, in some sense, a core aspect of what it is to be human. Van Gogh painting, The Good Samaritan, is in some sense the essence of a lot of what we think about when we think about basically the desire to help other people. And cooperation is so I'm going to use cooperation to describe all this kind of stuff. This is a topic of great interest across the social and natural sciences because it's so central to our life. By cooperation, what I mean is situations where, situations where people are willing to pay a personal cost in order to give some larger benefit to one or more others. So it's just sort of creating welfare for others. When the key feature of cooperation is that it makes everyone better off. That is, it's positively non-zero sum. Like if I am willing to incur some cost, not necessarily financial, it could be time, effort, risk, whatever, in order to give a benefit to you, and the benefit that's created is larger than the cost that's paid, that means that overall, we're better off as a whole. The sort of size of the pie is increased by this type of behavior. So it's a sort of socially desirable thing that we would like to encourage, but at the same time, it's often quite challenging to get people to cooperate because creating these kind of collective benefits requires individuals to bear personal costs. And so the key to understanding cooperation and thinking about cooperation is thinking about this tension between what's individually optimal and what's collectively optimal. So I'm going to start out by just giving you a few examples across a wide range of scales of the importance of cooperation in life. So I'm going to start at the very small end and start with these are yeast. They're very small little organisms. They're single-cell organisms, and they eat sugar, but they can only sort of extract. They can only uptake through their cell wall a certain type of sugar. And if you put them in an environment where the sugar is all sort of bigger form, like two of the sort of sugar molecules stuck together, what the yeast will do is they'll create an enzyme called invertase, and then they'll secrete it outside of the cells into the environment in order to break the sugars down into the individual pieces that then they can uptake. And so that's great because they can live, but the issue is that they have to pay a metabolic cost. They have to use energy in order to create those enzymes. And then once the enzymes are secreted, all of the sugar gets split outside of the cell in the environment, and it can diffuse away. And so that means there could potentially be free rider yeast strains that don't produce the enzyme and just kind of free ride off of the sugar produced by the other enzymes that are paying the cost to create the enzyme. If you think about a sort of key element of certainly human life, is the transition from single cellularity to multicellularity, where instead of single cell organisms, our bodies are made of vast numbers of cells, all sort of working together when they're supposed to, growing when they're supposed to, and importantly, not growing when they're not supposed to. So any individual cell sort of reduces its own growth and only grows when it's supposed to for the good of the organism as a whole. And that's a flavor of cooperation. And when that cooperation breaks down, an example is cancer. And so what cancer is a mutation where it changes the genes in the cell to all of a sudden say, okay, I'm not going to be cooperative. Now I'm just going to start growing as fast as I can and try to maximize my individual fitness, which then has disastrous consequences for the organism as a whole. Scaling up a little bit more, ants and bees are fantastic examples of cooperativeness where vast numbers of the SMBs work together, essentially all for the good of the queen. None of the workers reproduce at all. They totally sacrifice their reproductive success just to sort of help the queen reproduce as much as possible. Another cool example comes from this disgusting looking thing, which is a vampire bat. And so it's funny because they look kind of nasty, but really they're very sweet. In that, so what they do is they go out and they suck blood, right? That's their thing. But they will help each other out, where like if some of the roost mates, that is some of the vampire bats, like don't do well and don't find much blood, the other bats that did real well and got a lot of blood will like regurgitate some of the blood that they got into the mouths of the bats that didn't get any to like help each other out. And a lot of hunter-gatherer societies are very egalitarian in a way that is very much this essence of cooperation, where it's actually very similar to the vampire bat thing, where when they go out and hunt or gather, then it's standard practice in a lot of these groups that when they come back at the end of the day, everybody sort of evenly distributes what they either found or what they either hunted or gathered across all the people in the group, so that it's sort of like an insurance thing where on days that you don't do well, you're not going to starve. But obviously, that involves an individual cost, because if you, on the days that you find a lot, you would rather just consume it all and not have to share it with other people. But because everyone shares, everyone's better off. This kind of cooperative, doing things that are good for the other person is a core element of a lot of romantic relationships, where you're willing to put the other person's interest first and do things that are good for them, even though it's costly for you. And when people are not willing to do that, often the relationships don't go well or fall apart. It's also an important part of group endeavors, like playing in a rock band. This is me circa undergrad. And so in order for the band to be successful, everybody has to invest a lot of time in practicing and getting good. And if anyone doesn't practice, it screws up the whole band. So this is from pairs to small groups, and then you can scale it further to large groups like organizations. There's a lot of evidence that cooperation, that is the willingness to do things that you know are going to be good for the organization, like share a piece of information that you come across that's not relevant for you but relevant to someone else in the organization, or cover for someone when they're going to be out sick even though it's not part of your job, etc. Organizations where people are willing to do these kind of cooperative acts do much better on all kinds of different metrics than organizations where people are just looking out for themselves and only doing the things that their job descriptions forces them to do. And then there are sort of country level things like democracy. The idea of democracy is if everybody votes, that's good, and that sort of creates pressure on politicians to do things that are good for people. But it presents this exactly kind of cooperative dilemma, because any individual vote doesn't make any difference. And so from a sort of purely individual perspective, why should you be wasting your time going and voting? But if everybody did that, the system wouldn't work. And then you have global level things like conservation, climate change, issues like this that require individuals reducing their own consumption or investing in things like recycling, whatever, for the benefit of the world as a whole. And so what I'm supposed to see across all of these examples is the idea that you have this tension between the individual and the collective outcome, such that it would be great if everybody cooperated, but there are these very clear incentives not to cooperate. And so the key question that we're going to talk about today is, why is it that people cooperate, despite the potential incentives not to? And so if I were to ask you this, one very natural answer is basically it feels good. Like it's the right thing to do. When you help other people, you feel good. If you were to not help other people, you would feel bad. You feel ashamed, whatever. And so these kind of things motivate you to say, okay, well, I should do the right thing and I should cooperate. And that's true. Like, it is certainly the case that a lot of cooperation is motivated by things like, feeling, either feeling good to do it or feeling bad to not do it. But that is not the level of explanation that I'm primarily interested in and that we're primarily going to talk about today. That's what we would call a sort of proximate explanation. That is, that's like an immediate cause of behavior. this is so Tinbergen is this very famous biologist that made this distinction between proximate causation and ultimate causation. Proximate causation is things like, so here the trait or behavior would be cooperation, but it's like how it works, what stimuli cause it to occur, what biological or cognitive implementations underlie it, and so that would be things like what emotions make you want to cooperate, et cetera, et cetera. And that is certainly an interesting set of questions, and a lot of psychology deals with those questions. But another class of questions that, in my opinion at least, are sort of more fundamental are questions of ultimate causation. That is, ultimate causes are in some sense historical. It's questions about why the behavior would have come to be in the first place. Like, why did it arise? What makes it adaptive or functional? What's the function that it serves that makes it, sort of like a good idea? And so the idea of this distinction is that it's this core tenet of biology that is like really often misunderstood and overlooked by psychologists and social scientists more generally, which is that you can very honestly be motivated by, say, an emotion of like, love or something to want to cooperate with someone. But that's a totally separate question from why do you feel love in the first place? And the fact that there are kind of essentially self-interested reasons, some kind of long-run self-interest reasons that give rise to these proximal emotions that make you want to cooperate doesn't mean that you're being selfish by cooperating. It's just a different level of analysis. And so what we're going to spend a lot of time talking about today is trying to understand what are sort of factors that make it so that cooperating is actually in your long-term interest. And just to sort of emphasize a little bit more this proximate-ultimate distinction, I'll give one example from biology, which is sickle cell anemia. It's this disease where red blood cells, instead of looking like this like they're supposed to, they get all kind of folded up and messed up, and they don't do as good a job of picking up oxygen, and it has all kinds of negative health consequences. And so you could ask proximate questions or things like, what causes this funny shape? Well, there's abnormal hemoglobin, they form these strands that cause a weird shape. And so that's a proximate question of what mechanistically causes it to look like that. Or another proximate question would be like, what's the gene that gives rise to this? And they identified it as some gene up there, and if you have some different version of it, it messes it up. But the ultimate question is, given that there are these negative health consequences, like why does this gene still exist? Like why hasn't it been selected out? And the answer is that if both copies, so hope everybody knows you have two copies of each gene, right? You get one from each parent. If both copies of the gene that you have this sort of messed up form, or whatever the sickle cell form, then you get this bad outcome. But it turns out that if only one of the two genes, one of the two copies of the gene is this and the other one is the normal one, that provides you resistance to malaria. And so there's actually an adaptive advantage to having this gene if you have it in this sort of heterozygous only one copy version. And so it's maintained in the population because of this this overall benefit to having the gene. So that's the kind of perspective when I say why do we cooperate, I'm looking for those kinds of explanations. What is it that makes cooperation actually advantageous, such that it can explain why we would feel like, oh, hey, we should cooperate. And so in order to answer that question in a sort of compelling way, the way this field has itself evolved is to use formal model this. That is, rather than just sort of words and conceptual things and experiments, we want to actually do some minimal amount of sort of mathematical formalization to give you a language for formally describing social interactions in a way that's very clear what you're assuming, and it's very clear what the conclusions are. And what this language is game theory. And so the idea of game theory, which originated in economics, but then also got very heavily adopted in evolutionary biology and in people in general that study cooperation, is that you want to describe some given social interaction, and the way that you do it is you define a set of players, so the different people having the interaction. You say, what are the options available to each player? And then you say, for each possible combination of choices by different players, what's the payoff that each person gets? And here, payoff is not necessarily or even usually in units of dollars, but it's just kind of like in units of goodness of outcome. And so you can use this approach to take any kind of social interaction that you want and sort of distill it down into its essence of, who's interacting, what are the choices that the people have, and how differentially good are the outcomes depending on the choices that the people make. And then once you've distilled it down into this very sort of concise mathematical form, you can do things like ask, what are the strategies that should occur? Like, what should you expect to happen here? Either if people are being rational, or if there's some kind of selective process going on where good strategies become more common and bad strategies become less common, and so on. And then psychologists often also use these games as experimental paradigms. We can have people actually play the games for money and see what they do. So for using the game theoretic approach to study cooperation, there are various different games that people use, but the real workhorse that the vast amount of attention is devoted to is the prisoner's dilemma. And I imagine a lot of people have heard of the prisoner's dilemma. There's some story involving prisoners attached to the standard telling of the prisoner's dilemma, but I actually think that story is not very good and it's mostly confusing, so I'm going to skip the story involving prisoners and just describe what the essence of the prisoner's dilemma is. So in the prisoner's dilemma, you have two people, and they're playing this prisoner's dilemma game with each other, and they both simultaneously make a choice. They can either defect, which is a sort of non-cooperative action, means don't do anything, or they can cooperate, which means incurring some cost to give a greater benefit to the other person. In this example, I'm just going to say imagine cooperating means you give up 1 unit in order to give 3 units to the other person. And again, this isn't some abstract currency of just sort of like whatever is good for you, time, money, and whatever. So each person can decide, am I going to pay 1 to give 3 to the other guy, and am I going to pay 1 to give 3 to the other person? And so we've now sort of described, here's a set of, there's 2 players, these are the 2 possible options, and these are what they involve. And so then we can sketch out what are the possible payoffs for each player given each possible combination of choices, and we put it into a payoff matrix, which is like the sort of workhorse of game theory is payoff matrices. And so we can say, okay, there's 2 players, each player has 2 choices, and then we can say within each of these different cells, that is combinations of choices, what payoff does each person get? So let's think about first the case where both people cooperate. So if for each I'm going to have the player 1's payoff, comma, player 2's payoff. So given that player 1 cooperates, that means that she lost 1 point and gave 3 points to player 2. But now player 2 also cooperated, which means he lost 1 point and he gave 3 to player 1. And so if you add those things up, you get each person comes out with a payoff of 2 if they both cooperate. Now if they both defect, no one does anything, so they both get no payoff. And so here we see the first part of cooperation, which is that it's good. It's sort of socially efficient. It's positively non-zero sum. If both people cooperate, they're both better off than if both people defect. And so that's why cooperation is sort of good in some sense. But now let's think about the case where one person cooperates and the other one defects. So say that player 1 cooperates and player 2 defects. Player 1 just pays the cost and doesn't get any benefit, and player 2 just gets the benefit and doesn't pay any cost. And then the sort of opposite is true in this case. And so what that means is that even though mutual cooperation, where they both get 2, is better than mutual defection, no matter what the other person does, you individually always do better to defect than to cooperate. Because if the other person cooperates, you get 2 by cooperating and 3 by defecting, so defecting is better. If the other person defects, you get -1 by cooperating and 0 by defecting. So there's this tension between what's individually best and what's collectively best. And so if each person follows their narrow self-interest, they'll very clearly defect, and then they'll both be worse off than if they had been willing to go against their self-interest and cooperate with each other. And so the power of game theory, as I was saying, is once you define the game, we can say, okay, well, what should we expect people to do in this game? And there's any number of different possible solution concepts to a game, but The most common one is brought to you by John Nash, famous to all of you, I'm sure, because of The Beautiful Mind. But in addition to being the subject of a Hollywood film, he also is like the most important person in all of game theory and won the Nobel Prize in economics for this idea that I'm about to give, which is a really very simple idea of, it's called the Nash Equilibrium. And so Nash Equilibria are strategies that you should expect to have people play, and the definition of a Nash Equilibrium is you could say a given strategy, strategy X, is a Nash Equilibrium if, given that you know the other person is playing that strategy, you can't improve your payoff by playing anything else. That is to say, given that the other person plays X, you should also play X if you're trying to maximize your payoff. A different way of saying it is if both people are playing X, neither person can improve their payoff by unilaterally switching. That is, assuming the other person keeps playing X and switch to something else, you will not do better. And so to look at how this works in the context of the prisoner's dilemma, we want to know, okay, is cooperation a Nash equilibrium? Is defection a Nash equilibrium? Well, let's start by defection. So say that you know that say you're player one. You know the other, so player two is going to defect, and so you have a choice between cooperating or defecting, and defecting gives a higher payoff than cooperating, so that means the best response to defection is defection. And so that means defection is a Nash equilibrium. If you know the other person is defecting, you can't improve your payoff by doing anything other than defecting. If we think about cooperation, so given that you know that player two is going to cooperate, then you do better to defect than to cooperate. And so that means the best response to cooperation is not cooperation. The best response to cooperation is defection. And therefore, cooperation is not a Nash equilibrium. And the suggestion is that basically people will play Nash equilibrium. And in some sense, this maybe seems silly and often is sort of made fun of by psychologists by saying, oh, there's all this like complicated prospective reasoning. Nobody looks at a payoff matrix and starts doing calculations about Nash equilibria and figuring out what to do. So like, this is a totally unrealistic description of behavior, so why should we expect Nash equilibria to make any difference? But the thing is that it turns out that basically almost any process where people learn to do things that give them higher payoffs, or where some force like evolution causes agent strategies with higher payoffs to become more common, any process like this is going to eventually wind up converging to a Nash equilibrium. So it's this vastly more general concept than this reasoning, oh, if I know that person is going to do that, what should I do, and so on and so forth. And there's a huge amount of evidence that across many different domains, the Nash equilibrium is a really useful concept for understanding what people will do with experience. As if they get to play the game many times, they'll learn to play the Nash equilibrium. And so what this means is that if you were to have some population that was a mix of cooperators and defectors, and then have either evolution in a sort of genetic sense, if there's some gene that codes for cooperate and defect, and you're having reproduction based on fitness, or in a learning process where people are preferentially copying those who are doing better, what you're going to get is over time, defection is going to wipe out cooperation. And so this is another way of stating the puzzle that I started from, which is why is it that people cooperate? This logic and this sort of Nash equilibrium kind of analysis suggests people should learn to defect. And yet we see all of this cooperation that I talked about in the beginning. So the question basically is, how do we explain that? Or put differently, what's missing from the basic prisoner's dilemma description that is present in life that induces us to cooperate? And so the first explanation that I'm going to talk about is called direct reciprocity. And so the idea is, instead of just playing a prisoner's dilemma once, which is what the prisoner's dilemma assumes, a lot of times our interactions, particularly our important interactions, are repeated. That is to say, we interact again and again, so if I cooperate with you today, that will make you more likely to cooperate with me tomorrow. The relationship with our friends, our family, our coworkers, so on and so forth. And we'll see that really changes things. But so there was a question of, okay, there was a recognition that, well, if you played a prisoner's dilemma repeatedly, things might be different than just a one-shot game. But this is sort of in the early 80s, there wasn't a clear understanding of what good strategies for playing repeated games were. And so to try and get an answer to this, Bob Axelrod, who's a political scientist at Michigan, he organized a tournament. And so he invited all the game theorists that wanted to submit strategies, and there were sort of computer strategies that could specify as complicated of a strategy as you want, and then all the strategies would play together, a game that lasted 200 rounds or 400 rounds or something like that, and they would do a round robin where they each played each other, and they wanted to see who would win. And to everyone's great surprise, and I think probably Bob Axelrod's great delight, seeing as it made his career, it turned out that the winner was this strategy called tit for tat that was submitted by mathematician Anatol Rappaport. And tit for tat was extremely simple. It just says it's essentially like 3 lines of code. It's like start with cooperate on the first move, and then in every subsequent move, just do whatever the other person did in the previous move. And so it was by far the simplest strategy that was submitted, and it won. And so everyone was like, whoa, this is really cool. And so then Axelrod was like, all right, great, we learned something. Tit for tat seems cool. Let's do this again. And so they ran a second tournament, and it was exactly the same as the first tournament, with 2 differences. First of all, people thought the first tournament was cool, so we got a lot more interest. So we got 62 entries instead of 14. And second of all, everybody knew the outcome of the first tournament. Everybody knew that tit for tat had been the winner, and so presumably designed their strategies with that in mind. And I think, to everybody's even greater surprise, the winner of this second tournament, again, was tit for tat. So even though everybody knew that tit for tat was going to be in there, and knew that it had been the winner before, and so had designed, presumably strategies aiming to beat tit for tat, still it won. And then he did a third version where he basically just took the same 62 strategies, but instead of doing a round robin, he simulated an evolutionary process where the sort of frequency of the strategies in each round depended on how well they did in the previous round. Whatever, again, tit for tat won. And so that really kickstarted this whole evolutionary cooperation field, because people were like, wow, this is really cool, like what is going on. So we're going to sort of talk about what is the logic of tit for tat. We're again going to imagine this prisoner's dilemma payoff matrix that I sort of introduced before, where cooperation means paying 1 to give the other person 3. So mutual cooperation is better than mutual defection, but it's always better to defect than to cooperate, no matter what the other person does. And so now we're going to say the game is repeated, and just for simplicity, let's imagine the game lasts 6 rounds. Now, you could have the simplest strategy are ones that just cooperate in every round or defect in every round. We're going to call that all C or all D. And if you think about what happens when all C plays all D, just in every period, C gives, basically they're in this cell in every period where all C is cooperating and losing 1, and all D is defecting and getting 3. So he just gets -6, and he gets 18. And so all C isn't taking advantage of the fact that the game is being repeated, isn't changing its behavior, and so it might as well just be a one-shot prisoner's dilemma. If you're just always going to cooperate anyways, you don't get anything out of it, and always defect crushes always cooperate. But if you think about what happens when tit for tat meets always defect, it's very different. So in the first period, tit for tat cooperates and always all D defect, which is the same as for all C. But in all of the subsequent periods, tit for tat is just copying what all D did the previous round. And so that means that essentially tit for tat protects itself from exploitation after the first round. And so still in pairwise combat, if you like, all D beats tit for tat because it's able to exploit tit for tat in the first round. But when tit for tat plays against itself, they opens with cooperating and then copies the partner's cooperation, so they manage to cooperate every period for the whole time, and so they both get really good big payoffs. And so we can, and I should say I didn't put this up there, but when all D plays against itself, they just defect the whole time, so nobody gets any payoff, right? And so now we can say, okay, all tit for tat is taking advantage of the repeated interactions to condition its behavior on the partner's past behavior. And that essentially transforms this payoff matrix where it's no longer just unconditional, cooperating, or defecting, now we have tit for tat versus all D, and so we can fill in these entries. So when tit for tat plays against itself, they both get 12. When tit for tat plays against all D, tit for tat gets -1 and all D gets +3, so we fill those things in. And when all D plays against itself, it gets 0. And now we can do our Nash Equilibrium calculation again and say, okay, in this game, what are good strategies? So if you know the other person is going to play all D, then if you play all D, you get 0. If you play tit for tat, you get exploited on the first round. So still, the best response to all D is all D, which means all D is still a Nash equilibrium, even though it's a repeated game. If you know the other guy's going to defect, you should also defect. But now, when we think about the sort of cooperative case, if you know the other guy's going to play tit for tat, if you also play tit for tat, you get all these great periods of mutual cooperation, and so you get a really good payoff. Whereas if you know the other guy's going to play tit for tat and you play all D, you manage to exploit on the first period, but then on all the subsequent periods, you miss out on the benefits of mutual cooperation. And so actually, tit for tat becomes the best response to itself. And so what that means is that whereas cooperation is not a Nash equilibrium in the regular one-shot game, once you make the game repeated, cooperation becomes an equilibrium also. And so this is sort of like showing how you can, reciprocity or repeated interactions can really fundamentally change things. Another way of thinking about it, and this is sort of just walking through that same logic in a more general way, is imagine that your partner plays tit for tat, and let's imagine a totally general version of the prisoner's dilemma where we say that that cooperating means paying some cost C in order to give a benefit B to the other person. Well, if you know that your partner is playing tit for tat, then you know that your partner is only going to cooperate with you next round if you cooperate this round, right? And so then, given that, it means that the choice that you are facing, you're thinking, should I cooperate or should I defect? If I defect, I won't pay any costs now, but my partner will defect in me next round, so I won't get any benefits back. But if I cooperate, I'll pay cost C now, but assuming that I meet this person again, I'm going to get a benefit B from them the next time because they're going to reciprocate my cooperation. And so if there's some probability W, if you say the probability that you play with this person, with your current partner again in the future is W, then the calculation is essentially I incur cost C by cooperating, but I get an expected payoff back of B times W. That is, W is the likelihood that you see the other person, B is the amount of benefit that you get from them cooperating with you. So the expected payoff is B times W. And so as long as the cost is less than W times B and B times W, it's worth it to cooperate. You can rearrange this condition which says if the probability of interacting with this person again in the future is sufficiently large relative to the cost-benefit ratio of cooperation, then it's payoff maximizing to cooperate. And so the key idea here is the more likely it is that you see the other person again, or the sort of longer the average games that you play with the person. That is, basically, the more future interactions you have with the person, the more valuable it is to cooperate, and so the easier it is to get cooperation to be a payoff maximizing strategy. That is basically the logic of why repetition can promote cooperation. And this is now the example, or this is the explanation that has been given for a lot of cooperative behavior. Like, for example, with these vampire bats, the explanation of why they're willing to regurgitate blood into the mouth of their hoostmates that didn't do well is reciprocity. That basically the bats are keeping track of who hooked them up and who didn't. And if you don't give me blood on a night that I do badly, then I'm not going to give you blood on a night that you do badly. And there's a study that basically said what predicts whether one bat is willing to help another bat. And by far the most important thing was the amount of food that bat had received from the other bat in the past. And that was more important than other things in particular. So reciprocity is argued as the explanation for vampire bat blood sharing. Also, there's a lot of evidence from humans. I mean, I think just from your own reflection, you can probably see that that's a force that operates in your life. But also, we do these lab experiments where we bring undergrads into labs like this. This is the lab at Harvard where I did my PhD. And they sit down at computer terminals and play these games with money. And the players sit down and say, OK, now you're matched with a new partner. Say, OK, you have these two choices. Do you want to do A or B? A means paying a cost to give the other person a benefit, and B means not doing anything. What do you want to do? OK, this is what you chose. This is what the other person chose. This was what the payoff you got as a result. And then we say, there's a 7/8 probability every round that you play again with the same person, for example. And you say, OK, great. Less than 7/8, you play again with the same person, you make another choice. And then eventually we'll say, OK, now with interaction's over, you're going to be matched with a new person. Here's what you got. And you see that when people do these experiments, the greater the probability that you play with the same person again, that is, the greater the sort of continuation probability, the more likely that you have a future with them, the more people tend to learn to cooperate. And now this is a sort of meta-analysis of a bunch of different experiments from different labs where I'm going to show you the average amount of cooperation, that is the extent to which people open with a strategy that cooperates, as a function of, this is basically how likely there is to be another round relative to some condition, some theoretically derived condition based on the payoffs, where it's basically whatever. Don't worry about that part, but the essence is the further over to the right it is, the more likely they are that they interact repeatedly. And what you see is across a whole bunch of different studies, there's this very clear relationship where the more of an ongoing relationship there is, the more people learn to cooperate. And this in the literature is, in a cute way, referred to as the shadow of the future. And so the idea is the fact that you know that a future exists casts a shadow back onto the present and influences your current actions because of your concerns about what's going to happen in the future. Okay, so this kind of repeated interactions can explain why people often cooperate in dyads where they that have an ongoing relationship. So like why you would help your romantic partner when they need it, or your friends, or whatever. But there is a lot of cooperation that is clearly not of the form of I'm doing something nice for you because you're going to do something nice to me in the future. And again, just to emphasize, I don't mean that people are explicitly doing this calculation. Like when you help your romantic partner, you're not thinking, oh, well, I better do this so that he or she will help me out the next time. It's like you really care about them and stuff like that. But the logic is the reason that you should have come, like the reason that we should have come to have this emotion of caring is it motivates you to cooperate in this way that then turns out to be payoff maximizing, because if you didn't, you would face these negative consequences. Okay, so there's a lot of stuff of that flavor, but there are also a lot of situations where clearly you're helping someone that is not going to reciprocate the favor. So like if you see someone on the street drop their wallet, and you hey, you dropped your wallet, pick it up, give it back to them instead of just taking it for yourself. You're clearly not expecting that you're going to run into that person again someday, and they're going to return the favor. And there's all kinds of examples of this flavor. And so an explanation that has been proposed for this kind of cooperation is that you might be willing to help this person that you're never going to see again because there are other people around observing you that you may interact with in the future. So that if you help this person, they're not going to help you in the future, but some other observer might be willing to help you in the future. And this is sort of ideas of reputation. That basically, if you have a reputation for being a nice person, because you're helping strangers and stuff like that, that makes the people that you do see regularly more likely to want to cooperate with you. And so there's all equivalent sort of models, that's these formal game theory models and experimental data and empirical data showing that if you are being observed, it makes you more likely to help someone that's not going to reciprocate it because you're sort of interested in maintaining your reputation. So then you can zoom out further and think about interactions happening within social networks. So rather than interacting at random, usually you interact more with some people than with other people. You can describe these kind of phenomena with the tool of social networks, which basically says, okay, say there are some people that you're connected with, and those are people you interact with. There are other people you're not connected with, and those are people you don't interact with. And you can have the same kind of reciprocity principle that we talked about with tit for tat happening in the domain of social networks to the extent that people have control over who they interact with. So if you have the choice to break links with people or make links with people, that's a form of reciprocity. It's what we call tie reciprocity because you're making or breaking social ties. And so if you're a cooperator, that means you benefit all the people that you're connected to, and the people that you're connected to that are cooperators you benefit from. So these sort of mutual cooperation links are beneficial to you, whereas these links where you're cooperating and the other person is defecting are sort of loss links to you. And so if you have the opportunity to update, you might say, oh, well, hey, this guy, he is a defector. I'm sort of losing out in my interactions with him, so let me go ahead and avoid him and like not interact with him. Or like, oh, hey, look at her, she's a cooperator. If I were to interact with her, I would benefit from it, so let me sort of make links with her. And so what this means is that basically being a cooperator causes you to gain social capital and gain interaction partners, whereas being a defector causes you to be excluded. And so we have lab experiments where, these are actually online experiments, where we have people from all over the country log in and play these games again for money, where so each dot in this little picture is one player. And the blue ones are got people that cooperated, the red ones are people that defected, and then the little lines represent the network connections. So like this person is playing the game with these 3 others, this person is playing with these 5 others, and so on, and the size of the dot is proportional to the number of connections. And so I'm going to compare a case where they're just stuck on a network and the network can't change, with a case where it's a fluid network where they can make and break links. And this is just one sort of sample run from each of these 2 experiments. In the beginning, in both cases, you've got some defectors and some cooperators, and they're just kind of fairly randomly distributed around the network. And in the fixed network, basically what you have to see is that defection spreads over time, and in particular, the highly connected people tend to be defectors. And that's just a standard, like people learning to defect, because defection is payoff maximizing. There's no way to change the network, so there's no real incentive to cooperate here. Whereas in the fluid networks, you see a very different thing happens, where the network gets very dense, people are making lots of connections, and the defectors get pushed to the edges of the network, and whereas and have like many fewer connections, whereas the cooperators become central and get lots of connections, and as a result, earn good payoffs. Okay, then you can zoom out even further to sort of global level things, where your cooperative act benefits a very large group of people, like voting, or the entire world, like conservation, sustainability kind of things. And so here, you can't have reciprocity in the traditional sense, because if you reduce your energy consumption, that sort of benefits everyone in the world, and you can't selectively benefit other people that are also being ecological, and like exclude people that are not ecological from the benefits of your non-consumption. But still, reciprocity can motivate this kind of public goods, like large-scale cooperation, if you take into account the fact that behaviors of these sort of public goods type behaviors can be observable to the people that you have personal relationships with, such that then if you cooperate, other people are going to be more likely, that is, if you contribute to the public good, that can make people more likely to cooperate with you in your personal relationships. And so the key here is observability, so that your global level behaviors are linked to your, are observable to the people, so that they can link their personal actions towards you to your global behavior. And so an example of how this can work in the real world is a field experiment that my collaborator Reciprocity did with a power company in California. They're trying to get people to sign up for a blackout prevention program where they, on really hot days, everybody cranks up their air conditioning, and it makes a really big spike in demand for power, and that can cause blackouts by like overwhelming the power grid. And so what they want to do is they want to get people to agree to let the utility company like turn down the intensity of their air conditioners automatically a few degrees on really hot days, so there's not as big of a spike, and so it doesn't crash the system. So it's a classic public good kind of thing, crashing the system is bad for everyone, but like having your apartment a few degrees hotter is also a little bit bad for you. And also it's a pain to like be there when the installer comes and go through the sort of effort of getting the system set up. So we mailed like 1,400 California residents this flyer explaining this program. And then we said, if you want to sign up, there's going to be a sign-up sheet in the mailroom of your apartment building, and sign up. And then we had two different conditions. In the control, on that piece of paper, there was some personal code, just some random strings, a string of letters and numbers. And we said, if you want to sign up, just write your personal code on the sign-up sheet, and we'll sign you up. And then in the treatment, it was the exact same thing, but in addition to writing down your personal code, you also had to write down your apartment number and your name, which means now your participation in this public goods program is observable to everybody else in the apartment building who are coming in and out of the mailroom. And what we found is that the fraction of people signing up for the program in the anonymous control condition was only a third as big as the observability condition. Put it differently, make an observable triple participation. And then we also compared that to what happened if you offered to pay them $25 to do it, which is what the utility company had been doing before. And paying them $25 did essentially nothing. And this free manipulation of just having them write down in a literal way was 7 times more effective than the caching cycle. And so the point is, this stuff is really powerful and can make a difference in real world settings. And Arazueli and I run this Yale Applied Cooperation team where we work with lots of different organizations doing public goods related things of one flavor or another to try and apply these sort of basic science insights into actually getting people to be more cooperative in real world settings. So what all the stuff that I've talked about so far boils down to is the following. In social dilemmas like prisoner's dilemmas, you have this problem where defection always needs cooperation, even though cooperation is sort of more mutually beneficial. And all of the different things that I've talked about are different versions of creating future consequences, such that people can be reciprocal. I can condition my behavior towards you on your past actions, and that creates an incentive for you to cooperate, that in the future, I will be willing to cooperate with you. And as we saw in that example with the tit-for-tat payoff matrix, these future consequences transform the nature of the interaction, such that instead of being a social dilemma where it's just strictly better to defect, it becomes what we call a coordination game, which is to say, if the other person is going to defect, you should still defect. But if the other person is going to cooperate, then it actually becomes more payoff maximizing for you to cooperate. And so that can make it self-interested to cooperate as long as you're in a place where other people are also cooperating. And so this kind of thing is what I'm going to now call, it's switching from what I call pure cooperation, or these social dilemmas where there's not a self-interested motive to do it, and all these different flavors of reciprocity and observability transform pure cooperation into strategic cooperation, where there is this now long-term self-interested, payoff maximizing motive for cooperation. And I think that really explains a lot of human cooperation. But it's also interesting to consider, what if you are stuck in a situation where it really is a prisoner's dilemma, there's no future consequences, like what can you do about it? How do you get cooperation in the context of these real pure social dilemmas where there is no self-interested motive? And the general explanation is, I'm going to use sort of 2 different explanations from the evolution of cooperation literature. And this is stuff that can give rise to unconditional cooperation, that is just cooperating in a one-shot game. And so also this is stuff that could apply for humans, but could also very readily apply for non-human animals that don't have the cognitive sophistication to do reciprocity, which requires a lot of keeping track of who did what when, remembering that, and all that kind of stuff. So the first of these principles is called assortment. It's also often called relatedness. But the idea is, in everything that we've talked so far about, I guess except for the dynamic networks part, in general, there sort of has been the assumption that people are more or less interacting at random. And so cooperators and defectors are just bumping into each other and playing these games. But instead, the more realistic thing is that there's some structure of the population such that you're more likely to interact with some people than with other people. And if it's the case that the way that structure is set up is such that cooperators are more likely to interact with other cooperators and defectors are more likely to interact with other defectors, then that really fundamentally changes things, because the problem of the prisoner's dilemma is that the cooperators bear all of the costs of creating the sort of cooperative benefits. The defectors get to take advantage of those benefits without paying the costs. But once there's this sort of clustering such that cooperators are more likely to be sort of linked up with other cooperators, then not only do cooperators bear the cost of producing the cooperation, they also get preferential access to the benefits of cooperation, because they are more likely to be connected to cooperators than to defectors. And so this idea of assortment, again, is that not everyone interacts with everyone, which means that you can get these clusters of cooperators and defectors arising, where cooperators are matched with cooperators, defectors are matched with defectors. And the consequence of that is that cooperators can actually wind up getting higher payoffs than defectors. If you think about the sort of extreme case of this, where there's perfect clustering, where all the cooperators only play with other cooperators, and all the defectors only play with other defectors, then it's clear that you would rather be a cooperator than a defector, because the defectors aren't getting access to any of the benefits of cooperation. And then this is just a gradual thing, where the more clustered it is, the more sort of segregated in this sense it is, the more cooperation you get. Okay, now the other version is called group selection. And the idea here, again, it involves some structure of the population, but rather than imagining there's just some network and people are connected to the network and sort of get clustering, the idea here is that the population is separated into different discrete groups. And the groups have cooperators and defectors within them. And within each group, you have sort of evolution or competition going on that is just based on prisoner's dilemma payoffs. So if there's a group that has some cooperators and some defectors, just like in the one-shot prisoner's dilemma, if there's no structure, the defectors are going to beat the cooperators. And so within any one group, defectors will be cooperators, so we still just have our basic problem with cooperation. But the key supposition of these theories is that groups sometimes fight with each other. And this could be, or rather I should say, groups compete. And so it could be actual warfare, where the two groups go battle with each other and the winning group wipes out the losing group and populates their territory with some of the members of the winning group. Or it could be something more cultural, where groups that are doing less well imitate the strategies or adopt the laws and policies of groups that are doing better. But given that cooperation is sort of beneficial for the group, the key logic here is groups of cooperators are going to do better than groups of defectors. So when you get competition occurring between them, this competition at the level of the group will favor cooperation and will sort of allow cooperative groups to sort of wipe out and replace non-cooperative groups. So again, the idea is within groups, defection beats cooperation, but when groups compete, cooperation is winning, and so this can allow cooperation to spread. Of all of the mechanisms, this is the one that is most controversial because it requires really a lot of competition in order to get cooperation off the ground, and so there's an empirical debate, like in the anthropological record and stuff like that, about whether there really was enough conflict occurring between groups to get selection at the level of the group to work, but nobody debates the fact that in theory this could happen. Okay, so that is my sort of overview of the basics of the evolution of cooperation and different ways that you can get cooperation to occur. And now what I'm going to use the last 20 minutes to do is talk about something more psychological, or rather to sort of step back into the psychological domain and think about the role of emotion versus reason in cooperation, but to think about it in light of the sort of mechanisms and stuff that we were just talking about in the first chunk of the talk. So this idea of the tension between emotion and reason goes back very far. So Plato's chariot allegory is an example where it said the emotions are like wild horses and then your sort of reason is the charioteer that has to rein in the horses and direct them in a constructive direction. Otherwise, they go crazy and run off and do messed up stuff. And then there's been a long history of different people working with these kind of ideas. Some of the most famous recently are Kahneman and Tversky. They're behavioral economists. Kahneman won the Nobel Prize in economics, I don't know, a few years ago at this point, for basically introducing a lot of these ideas into economics and being like, you can't think of people as purely rational, deliberative agents, but a lot of times you're doing things in a more kind of emotional, intuitive way, and that leads to various biases and leads people to make sort of predictable types of mistakes in different domains. And now it's pretty cool that we get to add to this list also Dick Thaler, who won the Nobel Prize in economics this week, who is in Chicago, who also is a behavioral economist that does a lot of this kind of stuff. The basic idea here, these theories are usually called dual process models or dual process theories, and the essence of it, as I was saying, is sometimes we make decisions through rational deliberation, which is sort of what game theory is used to thinking about, what economics is used to thinking about, and I think by and large, when people think about decision making, they usually think about people thinking through a decision and then deciding what to do. And for the rest of the talk, I'm going to represent deliberation with this picture of my son, Isaac, who 1 hour after he was born was very carefully reflecting on the world in which he found himself and what he should be doing. And so that's great, and that is like an important part of a lot of decision making. But the point of these dual process models is that sometimes we don't think very carefully and detailed about things, but instead we just kind of go with our intuition, our gut response, our sort of automatic predisposition. And so I'm going to represent intuition by Isaac's identical twin brother Miles, who was not thinking as carefully about what is going on. And so the key idea, as articulated in Kahneman's best-selling book, Thinking Fast and Slow, is that you've got these two different types of reasoning systems, and you can slice this in a lot of different ways. Like you can say the intuitive system is fast, whereas the deliberative system tends to be sort of slow. The intuitive system is parallel, that is, can take lots of different inputs at the same time. It's kind of like a statistical learning thing, whatever, don't worry so much about that. Deliberation is sort of serial, like if you think about one thing, then you think about the next problem, and you think about the next problem. The intuitive response is automatic, it sort of occurs relatively effortlessly, whereas the deliberation requires exerting sort of cognitive control. They only really think carefully about what's going on, and so as a result, you have this effortless trade-off. Intuition tends to be about sort of making associations, whereas deliberation is more you have a set of rules and you think through things based on rules. And the intuitions tend to be relatively fixed and slow learning, whereas deliberation allows you to very flexibly switch between different things and different values. And also, the intuitive response tends to often be associated with emotional responses rather than deliberation. And so when you apply this framework to cooperation, you have the question of, if you're in one of these repeated interactions or something where there's a self-interested reason to cooperate, it's sort of obvious why people are cooperating. And so the puzzle that we're left with is why do people cooperate even in one-shot situations or even in situations where they know it's not going to pay off in the long run? And one possibility is that we have the impulse to be greedy and only look out for ourselves, but by exerting rational, deliberative self-control, we sort of overcome our intuitive desire to be selfish and make ourselves do the right thing. But there's also the opposite possibility that we're predisposed to being towards being cooperative. We kind of want to do the right thing, but then when we stop to think about it, the sort of calculus of self-interest makes us realize, in this situation, actually, I should probably be selfish, even though it kind of feels good to be cooperative. And whether it's one or the other, people have been debating, for thousands of years. But in recent years, psychologists have been starting to do a sort of serious empirical investigation of this. And I should say this is sort of what my research is about. A lot of my research is this question. And so the framework that I propose to think about what the answer should be to that question is as follows. We imagine, again, that sometimes we have these strategic interactions where there are self-interested reasons to cooperate if you expect the other person to cooperate. Other times we're just doing these sort of more pure pro-social things where we know it's not going to be self-interested to cooperate. And each time we're in a situation is one of these two different types of situations, and we have to make a decision. And so if you think about how intuition and reason work, if the idea is that the intuition is easy but inflexible, it just kind of comes automatically to you, but it's not finely tuned to the details of the situation that you're feeling, just kind of like a gut response. Whereas deliberation is flexible, it lets you think very carefully about the specifics of the situation that you're facing, but in exchange it requires you investing some effort and time, so it's sort of costly. Then you can think about what deliberation is about. It's about paying a cost in order to tune your responses to the type of situation that you're facing. And we can think about this in game theoretic terms. You can set up a model where sometimes it's one-shot games, sometimes it's repeated games. There's some probability of one versus the other. And then you have a strategy that can say, well, what do I do when it's my intuition? What do I do when I stop and think about it? And how much cost am I willing to pay to stop and think carefully about the situation? What you see is that there's two possible Nash Equilibrium strategies. One of them says, my gut response is to defect, and I never think about it. There's no reason to ever pay any cost to think. I don't care what the situation is, I'm just going to be selfish. And then there's another strategy, what I call a sort of dual process cooperator, whose gut response, intuitive response is to cooperate. You sort of think it feels good to cooperate. And then when they stop and think about it, if they realize that it's a strategic situation where there is a self-interested reason to cooperate, the strategy says, oh yeah, my gut response was right, I should cooperate, okay, great, let me keep cooperating. But if you deliberate and realize that it's a social dilemma, that is, it's a situation where there's no self-interested reason to cooperate, a situation where if you think about it, you realize you can get away with being selfish, then even though your gut response is saying you should be cooperative, the strategy thinks through and realizes, aha, actually, here, that's leading me in the wrong direction. I'm going to overrule that desire to be cooperative, and I'm going to defect. And you can say, okay, how likely is it to defect? Basically, it's willing to pay to deliberate as long as the cost of deliberation is greater than the probability of a social dilemma times the cooperation cost, which makes sense because if you think about it, in this model, what deliberation is doing is essentially letting you not waste money when it turns out that you're actually in a one-shot dilemma. Sorry, you're actually in a situation where you could get away with cooperating. So if you were to cooperate there, it would be a waste. It wouldn't bring you any future benefit, and you would waste whatever the cost of cooperating is. And so that means the benefit of deliberating is the amount of money you don't waste on cooperating times the likelihood that it's a situation where you could get away with cheating. You don't have to worry about the details of it, but this is sort of like, if you thought the game theory part was cool, whatever. Okay, so the point of this, oh yeah, right, and so this thing is in equilibrium if it's sufficiently likely that strategic interactions are happening. So if a pretty large fraction of the time cooperation is long-run payoff maximizing, then the best strategy is to say, let me make my default essentially to assume that it's a good idea to cooperate. And then if it's not too expensive, that is if I'm not too busy or tired or whatever, so it's easy for me to think about what's going on, let me stop and check if actually this is a special case where I can get away with it. But if I'm too tired or I have to make a quick decision or whatever, I'm just going to assume that it's a good idea to cooperate. And so this is this thing I call the social heuristics hypothesis, which says if you think about what intuitions are, they're kind of heuristics or rules of thumb, the behaviors that typically work out best wind up getting internalized as these automatic intuitive predispositions. And then deliberation lets you say, well, in this specific situation, does my sort of intuitive emotional rule of thumb make sense? And given that we're in a world I would argue where typically it does pay off to cooperate because of reputation and repetition and all the stuff I talked about at the beginning, it means usually the long run payoff optimal behavior is going to be cooperation. So you should internalize cooperation as your default response. Okay, so this is a sort of theoretical prediction, but then we can run experiments to say, does it actually look like this? And in particular, what this is predicting is that if I put you in a situation where there's no self-interested reason to cooperate, your first response should be cooperating, but if you stop and think about it, you should get more selfish. And so we do experiments. For example, we have people play a single public goods game. It's like one of these cooperation economic games. The way it works, you have a group of 4 people. Each person gets some money, and then they choose how much to keep for themselves and how much to contribute to a group project where all the contributions are doubled and split equally among the 4 people. So it's just a 4-player prisoner's dilemma. If everybody contributes, everyone doubles their money. For every $1 you put in, it gets doubled to $2 and then split 4 ways, which means for every $1 you put in, you only get 50 cents back. So even though the group as a whole is better off if everyone contributes, the best thing for you is to let everybody else contribute and you not contribute and free ride off of their contributions. So it's this social dilemma situation where no matter what the other people do, it's always payoff maximizing for you to not contribute. And then we want to make people rely more on their intuitions versus more on reason. And so what we do is half of the people who are sort of going to be in the more intuitive condition, we say, okay, please make your decision as quickly as possible. You have to decide in less than 10 seconds. And so that sort of pushes them to rely more on their intuitive response. And then the other half of the people, we say, please carefully consider your decision. You have to stop and think for at least 10 seconds before you make your choice. And so then the question is, who is going to cooperate more? Who is going to contribute a larger amount to the public good? The people that we induced to be more intuitive, or the people that we induced to be more deliberative? And remember, the prediction of the theory is these people should be relatively more cooperative because they're relying on the rule of thumb from daily life, where it's a good idea to cooperate. Whereas these people should be more selfish because they're stopping and thinking and realizing in this particular situation, you can actually get away with being selfish. And we ran it both in the lab with Harvard undergrads and online using Amazon Mechanical Turk to recruit people from all over the world. And what we found in both cases was the result as predicted, which is that the people under time pressure contributed more than the people under time delay. That is, the more intuitive people were more cooperative than the deliberative people. And so this fits with this idea that in one-shot situations, deliberation is undermining a predisposition, an intuitive predisposition towards being pro-social. Now, a principle, I don't know if, to what extent you guys have talked about replication crisis type stuff in this class yet, but a big theme in experimental social science right now is the realization that you shouldn't really take any one study particularly seriously, because it's possible that that's just a false positive, like either they got lucky or there was some kind of bad research practices in place that sort of predisposed them towards finding the result they wanted. And you can also have false negatives, where even though there is a real effect, the study doesn't uncover it, either because they just got unlucky or the sample size wasn't big enough or whatever. And so then there's been a big sort of push in the direction of, among other things, realizing you can't say, oh, I saw one study that showed something, it's settled, like that is clearly the answer. But instead, you want to look at the result. Ideally, if there's a question that's interesting, people will do a bunch of different experiments, and ideally people from different groups will do experiments about a thing, and then you can say, let me look at the whole body of evidence together and see what it looks like. And so meta-analysis is this technique where you basically give the meta-analysis, say, here's a study, a whole bunch of different groups ran more or less the same study, and each one got a different effect size. And so here, effect size would be the difference in cooperation between the intuitive condition and the deliberative condition. And then you want to say, okay, take all of this evidence together and say, what's the average, what's the real effect size that this suggests? And a simple way to do it would be to say, well, just average the effect size across all the studies. But the sort of better way to do it is you don't just average them straight up. You do a weighted average, where basically the more precise an estimate is, the more heavily it counts in the overall estimate. And this is measured by the standard error for people that care about the technical element of it. But so basically, it's like if one lab ran a study with a ton of participants and has like a really good precise estimate, and then another lab ran a study with only a few participants, and so it's very noisy, this meta-analysis would take the experiment with many subjects sort of more seriously than the one with fewer subjects. And so meta-analysis is a really powerful tool for aggregating lots of information together and seeing overall what happens. And so after that initial study of mine, a lot of people got interested in this, and a lot of experiments got run. And so I did a meta-analysis where there's 67 different experiments run by 26 different research groups, over 17,000 people in total. And when you meta-analyze it, the results confirm this sort of original suggestion, which is in situations where there's no self-interested reason to cooperate, so these kind of social dilemma, prisoner's dilemma type situations, you get 17% more cooperation in the intuitive condition compared to the deliberation condition. So when there's no self-interested reason to cooperate, deliberation undermines cooperation. But if you look at situations where there is actually a payoff maximizing reason to cooperate, so a repeated game or a game where the other person can respond to you, so there's a possibility for reciprocity, there the idea should be if what deliberation is doing is making you self-interested, here deliberation should say, oh yeah, the intuition to cooperation is right, here I should actually be cooperating. And so here, deliberation should not undermine intuition. And that's what we found, is there is essentially no difference in cooperation between the more intuitive and more deliberative conditions when there was actually a payoff maximizing reason to cooperate. And so, taken together, what this suggests is that for at least for the participants in these experiments, it's typically the case that the first response is to be cooperative and pro-social, and then when you stop and think about it, you think, should I actually be pro-social here, or is this a situation where I can get away with being selfish? Okay, so the last thing that I'm just going to mention real quickly is that, so far I have like all the experimental stuff that I've been talking about has in general been run with Americans or at least Western European college students, but there's cool evidence that there's big cross-cultural differences in cooperation. This is a work by Benedict Hermann where he ran things in 14 different countries that varied a lot in terms of rule of law and corruption, GDP, trust, norms of civic cooperation. And what he found is that the level of cooperation in these economic games varied quite substantially across cultures. And you can ask yourself, why should that be? And this story about social heuristics and sort of intuitive, like your intuition encoding behavior that typically works out well, provides one type of answer, which is that if you live in a country where there are good institutions, there's strong rule of law, there's not corruption, so there's sort of rules in place that incentivize you to do good behavior and disincentivize you to do bad behavior, that makes cooperation typically pay off. And as a result, that leads you to internalize cooperation and sort of be generally cooperative, even in situations where there aren't rules governing your behavior, even when you're not in a strategic setting. And so that can lead to creating a culture of cooperation, whereas the opposite is true if you're in a place where the rule of law is weak and corruption is widespread, there's not really much incentive to behave well, and so you wind up internalizing selfishness as your default. So just to summarize this, cooperation is this action that's collectively beneficial but individually costly. Future consequences can make it so that cooperation pays off in the long run and is actually strategically optimal. You can also get the spread of cooperation, even non-strategic cooperation, if there's population structure in place. When you want to think about cooperation from a cognitive perspective, you have this intuition, it's sort of fast, easy, but inflexible, and it's shaped by Sickle interaction, whereas deliberation kind of makes you think about what's specifically payoff maximizing. And cooperation varies across cultures, perhaps in part because good institutions can create intuitions that favor cooperation and therefore create cultures of prosociality. So that's my little tour of the world of cooperation. I hope it was fun.